Hello, everyone. We will begin shortly around 2:40. So everyone hold on. There is some technical problems that needs to be resolved.
Hi, Bala. You can start sharing again the slide. And then start our live now. Thank you.
Okay, very good day, everyone. Welcome to our third Makers Talk. I hope everyone's doing well and in the best of health. We are in the holiday season now, or I presume we are approaching this. Tomorrow is the 1st of May, which is Labor Day. So, as promised, we are back for our third and final Makers Talk. And for today, supposedly we have, hold on, please. We have 4 distinguished speakers today. For unforeseen circumstances, Mr. Eric Yue can't attend the talk today, so he will be replaced by Dr. Wong Chi Yan, our respected associate professor from University of Science Malaysia. And later on, we'll have our second speaker, which is Wong Chi Yan, who is Fung #1 primary school from Fung #1 primary school in Hong Kong. And then moving on to the third speaker for later on, around 3:30, we will have Ng Cheuk Yu from CMA Choi Cheung Secondary School, also from Hong Kong. And our final and last speaker for today will be Mr. Herman Yuhing Leong from PLK HKTA Yuan Primary School. Now then, as I said, this Makers Talk, this final Makers Talk is in conjunction with our main event. So please, if there are still some of you who are unfamiliar with what is Makers at USM International Virtual Fair, you can visit our main website here. And this website link will be pinned in the YouTube live chat, so you all can check it out for all the important details regarding registration, proposal submission, or if you all want to get to know the important dates and all that, everything can be viewed from this website here, as all 3 Makers Talks are in conjunction with Makers at USM International Virtual Fair 2022, which will be held somewhere in August. Now then, before I pass on to our first speaker today, which is Dr. Wong, some important reminders for everyone attending the meeting, attending the talk today. Firstly, since everyone who's attending this talk today via the Zoom, or those who are in the YouTube live, watching the YouTube live, you're required to fill in the attendance Google form, which is pinned again in the YouTube live chat box, because you will be given a certificate just for attending the talk today. And those who have attended the first and second talk will be also given a certificate. Secondly, like I said, if any one of you is still unclear about what our event is about, Makers at USM International Virtual Fair 2022, if there are still some of you unclear or who have still yet to register, today is the last day, the very last day for you all to make the registration complete. Go to this website or right here and fill in the registration form, because after today, you will not get a chance to register anymore, as today is the closing date for the registration. So please take note of that and do register quickly. And as usual, find out any important information or regarding the event. And later on, I will also share some details, intrinsic details about the website. And yeah, welcome to the third Maker Stop. Now moving on to our first speaker, I will pass over to Dr. Wong, who will be replacing Mr. Eric Yue. And the topic for this talk will be about innovation beyond tomorrow. Dr.
Hello?
Wong? Yeah.
Hello?
Yes, doctor, we can hear you.
Yeah. Can you see me?
No, doctor, we can't see you.
Oh, how come, how about this?
Now it's fine.
Okay. Hi, everybody. I'm Dr. Wong from USM. Okay. Since today our speaker, Eric Yu, cannot give the talk today, so he asked me to help him to deliver his talk. Okay, so I will try my best to explain what he want to explain to everybody. Okay, so the topic today is innovation beyond tomorrow. So innovation, we talk about innovation. That means for maker, we have to start to something like to use our hand to make to use our DIY skill to something like making the product. Okay, so okay, so after that, after we start to something like start to know pick up the skill how to make the thing, then later on we will have the skill to something like to innovate. So innovate is for beyond tomorrow. Okay, let me share the video that Mr. Eric Yu want to share with you all. Okay. Can you all see the video?
Yes, doctor.
Japan's population is aging at a more rapid pace than that of any other country. Autonomous driving technology and home robotics are two promising solutions to this challenge. These technologies promise to provide people of all ages and physical capacity the ability to move around independently and freely.
The latest AI technologies allow machines to learn from.
Okay, imagine one day when you travel on the road, you see a vehicle without a human driving the car. So what happened? Is it somebody else driving the car for you? No, because this is the autonomous vehicle. That means we use the technology to something like to drive the car. Okay.
Experiences adjust and optimize their operations and detect anomalies without any human intervention. We will make many of such machines talk to each other, exchange their experiences, so that they become more intelligent. These intelligent machines will certainly revolutionize the manufacturing industry. Cutting edge.
This sorry.
Japan's population is aging at a more rapid pace than that of any other country. Autonomous driving technology and home robotics are two promising solutions to this challenge. These technologies promise to provide people of all ages and physical capacity the ability to move around independently and freely.
The latest AI technologies allow machines to learn from experiences, adjust and optimize their operations, and detect anomalies without any human intervention. We will make many of such machines talk to each other, exchange their experiences, so that they become more intelligent. These intelligent machines will certainly revolutionize the manufacturing industry.
So later on, we are using AI, artificial intelligence, to something like in manufacturing, so that when the robot is having the artificial intelligence, is going to pick up the production things, and also they use it to assemble car and some other thing else. Okay.
The future of work urges enterprises to transform to the digital era. NEC's Smart Workspace provides a personalized dashboard through which you can smart your day and access all vital applications from any place and with any device. Maximize the performance of your mobile workforce and make them more responsive to business. Check availability and reserve a parking space. Make customer contact welcoming and well-informed. Check-in and room assignment is handled smoothly and securely. Unified communications allows teams to work together frictionlessly in real time with coworkers, customers, and suppliers. Choose a flex desk or just get a meeting room. Accepting a personal invite automatically ensures building access. At the office, location-aware services include wayfinding, managing temperature and lighting, and unlocking restricted areas as needed. NEC Smart Workspace ensures a rich customer and employee experience. It combines intuitive work streams with a better work-life balance for enhanced personal wellness. Let NEC empower your...
So just now, Mr. Yu is from NEC. NEC, they are having this network system, something like to some for their daily life. They can use for arrange for meeting and some other things. Okay. Then now is for agriculture. Since agriculture is something like producing food for us, our daily consumption, so it is one of the very important industry. So this industry is something like beyond tomorrow. Okay, is for our future needs. Okay, so in this video they are something like using this something like video to check the size of this cucumber. Okay. So another food that we consume daily is fish. So, but one of it is a tuna. So, in order to make sure there's a good quality of tuna, so the NEC or Japanese, they are using this AI method, machine learning method, something like to check the quality of the fish, whether the color from the color or from the texture. Okay. Right. So this is the three video. Next video is so now is the era for Industrial Revolution 5.0. We our world already within these 100 years we already go through the four industrial revolution. Okay, so now we are entering industrial revolution 5.0 already. For industrial revolution 1.0, that means before this industrial revolution 1.0, basically human are making their daily use product themselves. Okay, so they are making their own clothes, they are making their own shoes. There's no factory or manufacturing produce the clothes and the shoes for them. That's why everybody have a different design of shoes, clothes. Other than that, there is no something like making a vehicle, house, or there's no industry at all. So when start revolution 1.0, humans start to use machine and the process in the factory, they are making products to sell to the customer. Okay. So for industrial 1.0, the steam machine, locomotive machine is start using, whereas for industry 2.0, that time we start the mass production in the factory using the factory process method. Okay, and the machine become more sophisticated. Okay. So for industry 3.0 that time, there's a digital revolution. The computers start be used in the manufacturing. Then this read out the groundwork of computer technology in the this industry. Okay, you can see that in the picture, in the video. During that time, the computer is very big, like a room. Okay. In fact, in Industrial Revolution 3.0, humans start to use robot to run their manufacturing. Okay, and then some of the process is very manual. Then we can instruct the robot to do the work. Okay, whereas when come to Industrial Revolution 4.0, we start to use this Internet of Things. That means we can control the machine, the computer from far. Other than that, we start to use AI, artificial intelligence, to something like to improve the accuracy of the checking and for other purpose. Other than that, we also have a big data. We are collecting a lot of data. With this big data, we make the AI possible for manufacturing. Okay. So now we already entering another Industrial Revolution 5.0, refer to human working with the robot and the smart machine, so that the work can be carried out faster and more efficient. And yeah, we will have a better advanced technology for this Industrial 5.0. So normally for industry is we want for manufacturing, making the factory, basically they want to earn money. So by something like run the process more efficiently, then the factory, the manufacturing will earn more money from there. Okay.
Good morning. The forecast for today is sunny, 72 degrees. Perfect for light casual wear.
This video show the daily life of a girl in the future. Okay, you can see that she start wake up when the alarm clock is uh, calling her to wake up, and then the alarm clock is in three-dimensional. Okay.
Oh, you're doing it. Good job. Right arm in.
Look what I have for my genius. Love you too.
All about it. Oh, yeah, the blood's here. Wait. Come here.
Good morning. Please enjoy your trip. Please watch your step.
So after she wake up, and then she take her breakfast, and all the thing is something like live in future life. Okay, then now they are having this flying car to send her to uh, the school. Okay, without the parents to send her to the school. Okay. So this one, we are talking the live at something like 2050. Okay.
Visions begin with an idea. An idea of how we will live in the future and what we will pass on to our children. It's clear that the future must be climate neutral to provide a good quality of life. But how can we achieve this? The energy transition will change the industrial region of North Rhine-Westphalia dramatically by 2050. It's a unique opportunity. Climate action will be an innovation driver for a strong economy. There will be new jobs and new opportunities that will enrich our everyday lives. Fossil fuels won't be needed for energy generation anymore. Even large industrial facilities will run on renewables. This is how we will harness the power of nature. Electrification and digitalization will be part of everyday life and change the way we get around. Hydrogen and synthetic fuels will power goods transport. And alongside electricity, hydrogen will become the most important energy carrier for industry too. It will be generated using green electricity in electrolysis systems all around the world. Hydrogen will also change the way basic materials are produced. Steel, cement, glass, and basic chemical building blocks will be manufactured without fossil fuels. Waste gases will be converted into materials for new, sustainable products by turning molecules of hydrogen and other elements into new compounds. To make medicines, packaging, or smartphones, for example. All without polluting the air. The buildings we live and work in will be built from climate-neutral materials. And if a building has to be torn down, it will be recycled. something new. The aim of these processes is to stop emitting CO2. If that is not possible, a circular system will be established to keep the release and uptake of CO2 in balance. A climate-neutral industrial sector will change our world. Even major industrial regions will be greener and more sustainable. The technologies to achieve this already exist or are being researched. Together, industrial, scientific and political partners are refining these concepts and thinking beyond borders. To make this vision a reality. The future starts here. Climate action starts here.
Okay, from this video, you can see the future, what the future look like. Okay, in order for us, would like to be can innovate for the future, for the tomorrow. We need to start from now. If today you start to be the maker, you can something like start to making the product. You are picking up the skill to learn Arduino. You are picking the skill something like to learn 3D printer and the laser cutter. Then later on, you were also picking up the something like image processing, and also hold on. Okay. Later on, you are picking up image processing and something like Internet of Things. Then also AI. Then it is it is possible for us to move into the innovation for the future. So I think this is what Mr. Eric Yu try to present to all of us. Okay. I think that's all. Okay.
Okay, thank you, Dr. Wong. Now there are some questions from the participants that are watching this now. First question is Dr. Hold on now, where is it? Okay, first question. Agriculture has been a famous topic nowadays. Do you have any ideas or example of projects that we can do? I am a secondary school student.
Sorry, the secondary school student.
The question is saying that the student is from a secondary school level.
Whether he can making all these things, right?
Yes. As a secondary school level student, what project based on agriculture they can do?
Agriculture.
Yes. Any examples or ideas?
Okay. In my experience, I think for the secondary school, if they want to move into the future agriculture, then they must start understand what is the agriculture now. Let's say, did he have the experience something like to plant the vegetables, to plant the fruit trees, all these. Without that kind of basic knowledge, you cannot apply technology into the agriculture. So as a secondary student, I think they should pick up something like the fundamental skill first. Then later on, if they pick up something like Arduino and the sensor technology, then they can start to apply the technology into the agriculture. Something like there's a sensor to sense the humidity of the soil. So if the humidity of the soil not enough water, then there's another actuator to on the water to something like to plant the to moist the soil. Okay. Other than that, there is also another sensor about fertilizer. So they also can use that technology to something like to let's say when they detect the soil not enough fertilizer, then they can something like to put the fertilizer in the soil. Okay. Then to harvesting the agriculture, then they can use image processing method to something like to look at the fruits, whether the fruits or the vegetable already can be harvested or not. So I think this is, I hope this already answered their question.
Thank you, Doctor. Now moving on to the second question. Hello, Doctor. In the first video, the video talked about artificial intelligence. And in the second video regarding the cucumber, it talked about using machine learning to evaluate the cucumber grades. Do you think there's any danger in artificial intelligence and machine learning that can pose to us in the future?
Sorry, I'm not really get your question.
I think the participant asking is there any danger in artificial intelligence in the future?
Oh, whether dangerous or not if you
Yes.
use artificial intelligence.
Yes, Doctor.
In you mean in this agriculture? In agriculture?
No, I think it's just general. They did not say agriculture.
Oh, okay. I think everybody watch some of the movie talking about AI. So next time something like when we implement the AI into the robot, then the robot can repair the robot and the robot can innovate and invent another robot, right? So the one seems like there's another war between human and the robot already. But in my opinion, robot is created by human, right? So I think humans still know how to something like control back the robot. Okay.
Okay, thank you, Doctor. Thank you. I think that is all for now for the questions. Okay. Now we shall move on to the second speaker of today, who is Mr. Wong Chi Yan, whose topic will be on challenges and opportunities for school-based computational thinking, STEM curriculum under the pandemic. I shall pass the floor to Mr. Wong now. Mr. Wong, I think you're muted.
Is the voice is okay?
Yeah, now it's fine.
Okay, thank you very much. Good afternoon, ladies and gentlemen. Thank you for being here. I'm Cheung, and I am a primary school teacher. Me and my colleagues, Mr. Mong, come from Fung number 1 primary school. Today, we are going to share with you about the experience about holding maker course under the pandemic condition. I welcome the questions, but I must ask you to hold them until the end of the talk. And our focus will be on the challenges and the opportunities when that we observed during the recent periods. Here is the flow that we will go through on this sharing section. We will have a quick introduction about the background information of our school. And then we will talk about the challenges that we are facing in this moment. This brings us to discuss the next topic about the problems and effects based on the challenges on the final sections. After mentioning the problems, we have some ideas on solving the problems and found out what opportunities that we have. At the end of my sharing, we will have some 2 case studies that we applied this strategy and method that we mentioned before. Before I start this sharing, I would like to show you a short video to introduce my school. It's around 3 minutes long, and here we go. Okay, and this is a short introduction of my school. One of the special things of the videos is that it was created by our students. It is another long story to share. We back to our topic first. Our school was founded in 1932, and we experienced many changes. In these academic years, we have 29 classes, and we have 831 students at the time. And we joined several projects to enhance our experience and knowledge in our maker and STEM sections, such as we joined the Wi-Fi 100 from 2015, and then we have upgrade and and project from the 216. And also we become the model ambassador school, which is an LMS system, and I will mention that later on. And also we upgrade to the 5G STEM pilot school at 2019. And also we become as a resources school of Fung and also the STEM project partner school at 2020. And let's move on to talk about the curriculum of our Maker program. We divided the program into two subjects, which is information technology with computational thinking course and STEM course. The first subject, I mean the IT and CT course, was started at the 2016. And this course is mainly focused on developing students' knowledge, such as the coding skills and some of the concepts on solving problems, such as the algorithm, how they design the algorithm to solve the problem when they face on daily life. And the second subject was started at 2019, and which means it's just a 2-year-old kid in our school. As we saw on the picture on the left side, Mr. Mong are teaching students on working on their project. And the right side of the student are exploring the electricity principle on the lesson. The subject is using project-based learning design to raise their interest for a student to join their courses. And here is some software and hardware we organized on our IT with computational thinking subject curriculum. Also, it is a long story and very detailed things on here, but we don't go through too long right here. So we can understand that we have diversity in both software and hardware to teach our students to develop their skills and knowledge in their maker-based knowledge. And then have a look at this page of the curriculum with the STEM subject. I am always told my students that they are lucky. Since when I was a primary student, I don't have a subject that teach me how to design and make a creation to solve the problem that in the daily life. I just can learn this concept and from the books and the TV shows about the creator and the maker in Pearl, one of the channel on Hong Kong on a Saturday. So we're back to the curriculum that as we all saw on the table. We learned that most of the course are focused on the P3 and P4 students. It's because P5 and P6 students need to attempt the public examination for their secondary school. Thus, we don't want to occupy their time on STEM too much. And the second reason that we are finding the way to balance in both academic and the STEM side. So we are designing and developing the curriculum for P5 and P6 on the process. We're back to the P3 students. We have a modern farming course at the very beginning, and the courses we cooperated with some company in Hong Kong because they have the experience and they have the technology about how to develop a business, and also they can apply the business on our daily life to solve our real problems. So it is a great opportunity for the student to learn how to start up a business with their creations and also with their maker creations. And also, besides the modern farming course, we also have the block programming courses with the RTech, and we have the STEM courses also. For the P4 students, they have a STEM course and IoT course, such as this smart home kit right here. We are going to teach them through how to build a smart home by using some hardware and software skills. And we will discuss on this later on. Up to the present moment in this academic year, our STEM course covered a quarter of total number of our students, which is about 200 students. And we predict that the number will be more on the future months because we have some courses are ongoing. We decided to have some more courses for our students to develop their maker skills. And the curriculum was established several theories. Here is two main theories on our curriculum that we use. The first one is Dr. Kong's computational thinking education step theory, and the second one is the Lewis creativity theory. These two theories give us a framework and an insight on how to develop appropriate curriculum for our students to develop their skill and mindset and also attitude in the maker sections. Besides on these two main theories, we also apply many theories behind the curriculum, such as the design thinking process, positive psychology theory, and also the education psychology theories. And this leads us to my next section about the challenges. As we all know, the pandemic led the government announced the two phases about the suspension of face-to-face classes in Hong Kong. The first phases in Hong Kong is half-day schooling, and the second phases of the suspension is to stop all the face-to-face classes in Hong Kong. It is quite a hard time for both students, parents, teachers, and schools because we have to find a strategy to deal with such a hard time for the students. And the challenges raise the three main problems and effects to our courses. The first problem is that we are lack of the contact hours in both mixed mode and full online mode. Before the pandemic, the junior students have 22 lessons and around 12.8 contact hours per academic year, and the senior students have 44 lessons, which is about 25.6 contact hours per academic year. However, when the pandemic comes, all the students has only 16 lessons, which means they only have 12 contact hours per academic years. Although the changes of junior students is not much than the senior students, it has a great impact for our students to develop their mindset and skills on the maker sections. And I will explain it later on the opportunities and solutions section. And the second problem is about the changes of students' learning method. Before the pandemic, as we saw on the before photo, our students can walk around in the classroom. We have a high interactive with each others. They can brainstorm with and share their ideas with their friends and even teachers. Every student seems so happy during the lessons. But after the pandemic, most of the students only have the online lessons. So the interaction between the students are decreased, and the interaction is limited. And for the first problem of our students are the facilities. Since our school provide all the equipment, devices, and the materials that student needs with full support before the pandemic. Now they need to prepare everything by themselves and do the project by their own. So how do we solve this problem? And for the first issue, which is about the lack of the contact hours with our students, we apply flipped classroom as our solution. We ask the student to finish all the lesson material, such as the tutorial, video, student notes, and readings before the lesson. But there are questions come to us about how we make sure all the student has go through all the material. And the answer is we set up a small quiz to check whether the student are finished all the materials or not. We understand that we no need our student understand 100% can go through all the material, but we want the student to understand the concept and the knowledge before the lessons, so they can go through all the quiz and the test. That means they understand what will going on the lessons. That is the important things for us to know there. And this drives us to another solution of the second issue, which is about the student and lack of the facility at home. To deal with this problem and enhance the efficiency of our course, we applied the blended learning strategy on it. We separate the lesson into two parts. The online sections is the teacher-based and shared the skills of optimization and assessment of the students' homework. Since we require the student need to prepare some questions before the lessons. After the online sections, the lesson turns to be students-oriented, as we ask the student to observe and test their creations and their idea. They will make their device and also their homework by themselves after the lessons, and then we can have more discussion on the lesson to guide the student to solve their problem they are facing. Also, to support this strategy, we need to deliver the material to our student in both virtual and digital way. For the virtual materials, we can divide it into two types of the questions. The first type of the student is the local students, and the second one is the non-local student. For the first type of the student, we packed all the things students need together, and we will mail directly to our students. For the second type of the student, we will help them to order the material from the online store. In Hong Kong, an online store we use most is called Taobao. I think most of the international maybe use Amazon. That is okay. After mentioning the virtual materials, how to deliver, and then let's talk about the digital materials, how to deliver to our students. We use LMS such as Moodle, and we also use Google Classroom to deliver the materials to our students. For the last issue, students did not have enough facility at home, so we offered a borrowed devices program for our students, which include a laptop, Wi-Fi 8, and etc. If a parent need the technical support, they can also come back to school, and our staff will give a helping hands to them. Besides, we have a BYOD program, which is bring your own device. So most of our students have an enough support for their home study. Although the facilities of students is not perfect as school setting, they can still have the lesson on their home. Now we are going into the case study sections. And I'm going to share two cases for you. The first case is the STEM C project, which is mixed mode on half-day schooling period. And the second one is the modern farming project, which is full online mode. For the STEM C course, we have 3 units for our students to play with. The first one is asking to the student to create a game which interact between the Mickey and Scratch. And the second topic is using M56C to create a smart trash can. And I have one of the creation on my hand like this here, which is cooperated with 3D printing. They can have some simple mechanism principle right here. That is a quite interesting project to ask the student to design a 3D model, and then they can print it out. And the last topic is about the AI elevator creation by using Hello Code. And then, which is using the hand posture to control the movement of the elevator. We always upload the materials to the LMS for our students to have the pre-study, such as how to build up the model at home, and also they can program and download the software at home also. Then the student bring their design and solution to the lesson. We can discuss why they are doing the design like that way, and then we provide some advice for them to improve their design. After the lesson, students need to finish a worksheet and homework through LMS again. This learning mode we call O2O, which means they need to prepare the knowledge and some concept on the online before the lesson. And on the lesson, we offered some opportunities for the students to discuss, and also we provide an assessment for them to improve their creations. And then for the online section, we are going to let the student to check whether they have some concepts or skills they are missing. So this model is referenced by the marketing strategy. Okay, for the modern farming course, which is an interesting course in this year, we also applied some structure as STEM principle courses. But one thing that different is we organized a VR tour for our students to visit the farm. It is a great experience for the student to explore the farm at home. Since in Hong Kong, we are locked down, and then our students cannot go out from their home. So this is a great opportunity for them to experience the outer world, to learn more what is going on outside. Also, we found another interesting things during the course, because the content of the course inspired our students to try to do the experiment that we didn't ask them to do so, such as they try to use the seed that we do not prepare for them, because we prepared 2 types of the seed, such as apple seeds, and also we prepared the orange seed. But some of our students are trying to plant with a lemon tree, and also the other seed, they want to try and study what is the difference between the seeds. That is an interesting things we found. And also, they shared what they observed during the lesson, such as why the color of the leaf is changes. Some of the students didn't. Maybe it's the lighting is different, or they are finding the factors that affect the result of they are getting. And this learning experience is very important for our students to develop their motivation on maker education, because most of the questions and issues need to found by our daily life. So we are encouraging our students to find out the questions and problems on their daily life. And at the end, thank you for your attention and joining these sharing sessions. And please feel free to ask me questions.
Hello, sir, can you hear me?
Yeah, okay, of course.
Okay, there are a few questions from the YouTube live chat box. I'll just read it to you, yeah?
Okay.
Okay, the first question is from a student. Do you think the coding skill is hard to learn by primary students? I have no coding skills, but I wish to learn it for the Makers project.
I think the coding skill is must for the primary student to learn, because we understand that most of the skills can be simplified by the game, such as we have some, such as like the Blueboard and the Scratch Junior. We educate our student by simple algorithms such as looping. What is loop is we're going to use some daily life example to, such as the sequencing. When they get up at the morning, they need to have a breakfast, and then they need to tidy up their backpack and then back to school. They will not to turn around this step. So the sequencing can be daily life, using the daily life examples for the student to understand what is the concept is. To connect the concept with their daily life, they are easily to understand what we are going to do with programming, because we are going to use our experience to teach the computer to do something. So we have some rules and ask the student to list out what they have to do, such as the diary, to what they do every day, and then to ask them, can they using the program to let the computer do the same thing too. So, and then for the other hand, we are trying to not to let the coding is very difficult, because we are applying the concept of the computational thinking step, such as which is Dr. Kong suggested for us. We always we practice these skills and knowledge for many years. So I think we have enough experience and knowledge for teaching the student on related concept and skills. And also, we are not going too deep for some sections, because we understand that some of the concept is very hard for a student to understand. We referred to Piaget's developmental theory about that most of our students develop their skills by looking at something. They have hard time to get the abstract concept from the age of maybe P1 to P2. So we will have a suitable organize the courses content for the students to develop their skill set. And also, for example, we use Mboard. We don't ask for the student to build an Mboard at P3 level, because they may not have enough skills and their mindset to do it. So we just use the Mboard to teach them some very easy and very understanding concepts, such as how to call the Mboard to our maze final point, and then they have used the Mboard to solve some easy problem. And then that's kind of the scaffolding for the student. I think is the best way for them to have a better prepare for their secondary school life. Thank you.
Thank you, sir. Now moving on to the second question. What are the projects your school has done, primary school has done? Can you share some? I think they're talking about the competition projects. So.
Sorry, pardon, because I'm not quite.
The question is asking, what are some of the projects that your school has done for competitions?
Okay. Our school have done. Wait me a minute. I need to take a project.
Okay. Okay. No problem.
Wait a minute. Sorry for wait for a second. This creation is one of our students' creation for the competition, which can help the student to express their emotions. As we all know, most of the students, especially for the junior student, they are hard to express their emotions. So they are creating a mask that with a microbit right here, but I think it's the background blurred. So I'm trying to show you the mask here, used to microbit to express what they are feeling with the motion. So it is an interesting project for the student. They can explore the psychological way and also the engineer way. And some of the project is too big and not here right now, so I can't show too much project in this moment. But we joined a few competition in this year, and some of our students get a quite good results, such as the silver prizes. So I think our student is quite smart and quite hardworking in this moment. Thank you.
Okay, sir. Last question from the audience. What are some of the challenges your school had to face when implementing this curriculum, this information technology, the ICT curriculum? What are the challenges?
I think one of the challenges is to integrate so many theories together, because we need to consider the ability that our student has, and also we need to consider the theory is suitable for our school's environment enough. Because we all understand that students have their learning differences between their classes or individually. So we will adjust the curriculum and the theories every year or even every month. We will have some meetings to talk about the performance of our students, because we understand that some of the students are slow walker. They need to have more support on coding education or even the maker education. We understand that there are several types of the learners, such as some of our students like to watching some pictures to learn the concepts. Some of our students like to listen to some sound and to learn the things. So students are interesting that we need to adjust our curriculum each year, and then we implement some theory that's suitable for our students to use. One of the interesting things, because I have a master in psychology, so I consider more about how to develop the student in a psychology way, such as we applied the developmental theory by Piaget and also Sigmund Freud, and this kind of the theory, and to mix with some of the computational thinking theory, that is an effective way for us to assess, to understand what the students need, and then to give them the most suitable support for our students on the lessons. Thank you.
Sir, one last question, because I think some participants are a bit confused.
Yes.
They're wondering, are the STEM programs in the main curriculum, or are they being carried out as co-curriculum activities?
Sorry, the question is?
No, they're asking, this STEM program, this curriculum, is it in the main syllabus, meaning students are forced to take it, or is it an extra activities that's optional for the students?
Oh, in fact, we have on our lessons, we have an on lesson time for them to learn about the STEM. And then we also have the extra activities for them to join, such as another elite programs for the competition, because we don't have many resources for all the students to support all the students to join every competitions. So we have the in-class subject, such as we have the STEM courses, and the information you can go to our school website to learn more about how to we develop the STEM subject. And also we have an extra activities for our students to join with. And that is a 2 level for our students. One is the elite subject, which is they always go outside to help them to develop and then join the competition for the academic year. And also we have some extra activities for them to join, such as a FPV courses, such as and other interesting courses like the some basic microbit course, something like that. And also we have the AI courses and AR courses to teach our students how to develop the 3D model, and then the AI courses. But because we have limited content hours in this year, academic year, so we cannot integrate all these things on our classes. So we will add it in the future, maybe for P5, P6 student. But in this academic years, I think we cannot integrate all the courses in our classes. Thank you.
Thank you very much, Mr. Anston. There are some participants who are very interested to exchange ideas with you. Is there any way that these participants can contact you?
Oh, of course.
Will they contact you through your website or email, or
maybe I can share my email to you.
You share it in the chat, and then we will post it in the YouTube live there.
Okay, of course.
Okay. Thank you very much,
You're welcome,
Anton. Okay. Now we shall move on to the third speaker for today, which will be Mr. Ng Cheuk Yu, and his topic for today will be on place-based learning for innovation design. Mr. Ng, you can take over the floor.
Yes, thank you. Yes, here we are. So a moment, please. So yes, good afternoon. Hello. Yeah, I would like to share my screen now. Yeah, a moment, please. So I will try to, yes, let me click on here. Sorry to letting you wait for a moment. So today the topic we are talking about how to use place-based learning to facilitate maker educations. So just some basic information of our school. I come from Hong Kong, from CMA Choi Secondary School, and there is the content for what we're going to talk about today. Some background information, the vision and mission of maker education, professional maker training for not only for STEM teacher. I think even though we're talking about place-based learning, but it's very important for us to include those teachers who are not from STEM or join the STEM education. And then some place-based example for how we promote maker education in school. Okay. So basic information. Our school was why we were interested in maker education is somewhat due to our background in Hong Kong. That's a kind of school is like a diploma school in 1970s, 1980s. They are aimed at training some people for the industrial purpose. So we were continuing training those technical stuff for Hong Kong, but nowadays they call them maker. Due to different reasons. Maybe some of them make something due to the hobby that are not so in the market. Maybe some of them due to the industrial 4.0 with the use of different small prototype making machine like 3D printed. They will start crowdfunding. So anyway, we have a background of training those maker talented students. If we review our school mission, why we're so stressed on it, because we are aimed at our school stress on importance of technical and commercial knowledge, create an environment for students to develop self-discipline. So we aim at day one, we want to train more students in the technical field and commercial field. Just some very brief introduction about myself. I work as a STEM education coordinator here in my certain school. I'm also being the first maker competitions, the one student, one invention, innovative design contest, and I also being several appointments in some teacher professional association in Hong Kong, and I keep holding a famous one in Hong Kong technology and renewable energy event, which promoting solar car competition as well as other renewable energy related robot making. I'm also serving as a open exam marker in Hong Kong, and of course, I think as a marker, robotic is kind of quite common topic, and I also running several match and conducting a professional curriculum development for a famous robot platform. Okay, so STEM, I would like to do it very quickly because I think everyone are familiar with that. I think the most important why we train maker because it could help to engage how to solve a daily life problem instead of just reading or just comprehensive something. Why we do it for Hong Kong school? Because we want to maintain the city productivities. According to some research in USA, for the career same with same level, if they are related to STEM, they probably have 40% more salary with compared to same level of position, and we have to compile with the city development needs. Okay. Now, first of them, we would like to introduce one of the things we do for maker or for place-based learning. We always believe that if we want to promote maker education, one of the best, one of the big points that we always stress on having those things with STEM-related teacher, or when you talk STEM, or go ICT, or go to the general technologies people, go to the math department. But I think I agree with that because we have to kickstart with, we need some pioneer to kick off the maker education in the school. But however, after the kickstart, you will find out that that is very hard for you to make the scale larger because the workload or the idea are mainly focused on a small group of people. So our school, one of the characteristics is that we believe that we should train also those other teachers who are not teaching STEM and having their idea into the project. Later on, we'll talk about it. Background. The scheme was funded by a school-sponsored related foundation, which called Choi Foundation, and we are aimed to build up a professional development community for STEM educations. Objective: perform for innovative educations, platform for innovative educations, promote STEM development, and we provide a series of professional development activity, and also maybe it's not related to education, we will do some teaching method research. Under that, we'll have student invention program. Sorry, there's some Chinese content there. This is one of our student pageant recognitions there. Our school, through the program, which funded by Choi Foundations, we will do several things. For example, we will, from our daily life, we will have some special room. Later on, I will show the picture, including the STEM center, including the robotic lab. Our school keep holding a robotic competition for other school, as well as our school is the Hong Kong representative for Westworld Championship. But how we do it? We have different special room, and those special room have a role manager for helping students to do it. Now, one of the examples is that we have STEM lab. And the stand-up later on, I will show you some picture that the fabrication machine that we have, like 3D printer, like laser cutter, like those Professor mentioned before. We also have CNC mailer. We can walk around our lab later. Okay, I just inside of my lab now. And the point is that other than the lab, we have to make sure that we have a manager for the topic-based learning. If a price without a manager, this is no use. Now, one of the very popular academy in USA, we're talking about the Fat Academy. Now, this is the concept from Fat Academy. If you are going to want a price, you gotta have the people as well as the machine, or the student were very dangerous to work there. One of the results that we got is that we got numerous of invention award, as well as we got 6 patents in these 2 years. Okay, so later on maybe I walk around the group. Yeah, building community through competitions and activities. Now, communities will not be formed, or even you got a prize. The teacher, the student, they won't go to you directly. So how do you use the prize, or you got a room? You got to provide some competitions and activities, and then the maker of student and teacher, they will later on got some topic to discuss. Okay. Okay, for example, this is one of example that we're doing that in Hong Kong for teacher maker training. Now, one of that is this is one of the maker competition that run in our school. We have some short movie. Oops. Oh, some technical problem. A moment, please. It seems some technical problem there. Hold on. Oh, maybe that is some technical problem. Sorry. Maybe later on when I have time, I will try to double check it. Now, this is one of the maker competitions. On show that is the robot lab in our school. Later on, I will show. If you don't mind, I will remove the background and show by the computer camera. Now, some people for some school, they may very hard to start maker education. We can start from a little step. For example, paper aeroplane. If someone has some understanding of it, actually this topic is very hot in the STEM education. That is well content of paper plane as well. So our school, in order to build up the maker community, will provide training for both students and teachers, especially primary teachers, to kickstart their kickstart their maker education. And later on, there will follow up workshop that some pictures show that actually paper, especially designer paper, can be used as a basic model or element for building a prototype model as well. We'll show it later. So this is some of the community record. The content already got 2,000 participants in two sessions, and other than that, in order to promote maker education, our school also formed a content for facilitate different kind of students for being a maker. Now, the content have already started in 2021, and that is more than 178 participants for the first year. We promote education, but more important is that we have to have a step-in step for the student. So we provided with an option the participants can hand in their design drawing as well. Just like what mentioned by Mr. Wong, during the pandemic, this is very hard for us to have a very big exhibition to show what the maker has made. But of course, that would be very nice. And later on, we'll share some plans with everyone. And for the next stage, other than the robot lab, other than the STEM lab, other than the a showroom. So next step, we're trying to build a metaverse room for some distant product showing or some other purpose. Okay, and if the students are very good at making, they can go to join the product design competitions, and we're going to promote that to a quicker Delta Bay in China. Okay, this is another base-based learning of a school. So for this part, we have some patent. We have more than 30 invention on hand. But however, when we talk about base-based learning, many people were thinking about a workshop, a wooden workshop, a mobile lab, or we got a lot of laser cutting things. But I think base-based learning is other than only the technical part. It is very important for us to have a room to show what the maker have made, and to let the student or to let the maker to get inspired by other design. But of course, we have to tell them, you couldn't copy other ideas. This is a kind of intelligent properties, right? So it was funded by CCK Foundations. We aim to provide quality innovative education. We believe that with all those inventions surrounded, students can learn pretty well about patent education, and we will display all those award recognitions and telling the student that you can do it as well. They are no different from you. You study in the same school, etc. So this is the house of honor or the room. We will place those very elite patent cert or some top international match award there. So that will be different show display boards there with different award there. This is some media media press about the room and what we have done in Hong Kong about STEM education. This is later on we can go out and check it. Actually, just next to me. We accept the place-based learning. We also design a launch to tell our students, maker is not something new. Maker is happening in 30 years ago. We tell the students about how our school trained the maker through different place-based learning. Professional development, just mentioned it before. If you want to train a maker, we got to train the teacher first. Sorry, some of them I didn't finish in Chinese, but I will explain in English. We will do all these activities. Okay, we will provide the teacher to visit to those places so that the teacher and the student can learn very easily. One of them is a mass laboratory. Okay. Well, actually, we find out that if the teacher doesn't go to that place, they really doesn't know that what is telemetric control, what happened there, and they can never imagine how they remove the dust. Yeah. Okay, they won't know it. Just like mentioned before, we will have airplane training workshop for teachers. We'll invite some entry elements to explain to us how the enterprise runs, because as a maker, some of them may want to be a kickstart of a business. Okay, and just like what I had mentioned before, Dr. Yuan is one of the very famous maker in Hong Kong. So because some of the school, they have some limitation, especially for primary school. We always talk with primary teacher, and we always find out that one of the most difficult points for, I don't know, maybe some primary teacher do not agree with that, but some of the primary teachers told me that they cannot have a maker education easily because they will not have technology lesson in primary school. They will not have saw, they will not have laser cut down there. So one of the ways is that actually, if someone is technology background, they know that paper prototype is one of the very common prototype in design house. So for Dr. Yuan, he specially decided a paper cut. Now this paper cut is talking about they have some alignment, they have some die cut, they have some hole, and they can easily be formed into different prototype. So that including some motor car and also some drill. And A moment. Okay, next. Now, this one example. Okay, this could be built by anyone in maybe just I mean one part. This is the paper model for a Chinese space station, and it's all built up by a same hub. Yeah, and you could see that in the picture that is they can use the paper with some motor to build up different robots there. So this is one of the way we suggested if we want to kickstart a maker education in primary, that will be one of the options. How we start it if you don't have a place or tools. Okay. So yeah. Okay. So a STEM school-based example later on. If we want to have a place for learning or we build a maker education other than the place, so how could we do it? Okay, we have to do this in our school example. We try to conduct these activities using the space, including the basic curriculum. We do some input for the student. It's not possible if we try to train every maker without a basic foundations. So for our school, we will give the training of Tinkercad, a 3D modeling for all for one student, because it's quite easy. Because for daily curriculum, you have to make sure that all students can finish your homework. Okay, we will have some post-school activities to build up the maker atmosphere. Of course, it's very important. It's not possible to push all the students to the top, but we will pick up some potential students to give them a one-to-one intensive place-based training in our special room. We will run some robot games to promote and to share our robot room to other primary teachers for facilitating their teaching. Curriculum Form 1. This is what we do. Well, I go around and show you something. Okay. I hope that they could see. Maybe I close the blur. Can I? Let me check. A moment, please. Let me check whether I can close the background blur. Background. A moment. Stop sharing first. Let me check how can I switch off the background blur or else. Okay. Now, some of them. Okay, yeah. This is one of the small project by one student. He just take an idea from some things given. When you see a different angle, you can see different shape. But due to the I got to check how to switch off the blur mode because I cannot show you the wheel place. Yeah.
I think you have to go to your chat top right there.
Chat,
will show mute and there's like the dots, 3 dots.
So, maybe it's what the video option is talking about. Video filter.
Virtual background.
Virtual background. Yeah, maybe I switch off for a while first. None first. Yeah. Okay. Now this is one of the things we're working on. We will facilitate the place with more than 10 there. And this is one of the mini projects that our students tried before. If you look at it from different angle, you will see they look like a triangle or rectangle or circle. They get an idea from things give something and they further define it. Now this is and other things. Now this is not the regular curriculum. Some students they will use the actually they don't need to draw it. They take it from some web and they try to make this to learn mechanics, how the gear ratio change. Now for this part, now this is the project that I mentioned in the PowerPoint that every Form 1 student have to do it. They build up a gadget holder for 3D printing. and they will learn how to fulfill the user needs. For example, I will just tell them, okay, whatever, you just go and pick up 5 things from your desk that is on your own desk. And then he have to think how to put all these things into a gadget holder. And the assessment criteria will be built that you should allow all the parties accessible easily. Now, some of them, just some good example, and that example among them. Let me take out 2. This one is good example because every object, every whole, they could be accessed easily and independently. And another objective is that the student have to guarantee that the phone put on there will not make it fall over. So they will learn, they will, through the metric educations, they also learn how to try and error. Now that thing is very important. Even when I first conducted this project in the first year, I really don't know those difficulty that will come across, and I did not make the assessment paper quite accurately. But for the second year, both teacher and student learn. I learned how to make an assessment paper with this project more accurately, and the student learned how to making their own things, and a lot of things. It's very hard for me to control. Maybe a flipper. Different things made by students when they come. So this is one of the things why we have a place-based learning, because this comes very naturally. I didn't force the student come, and the room is there, and students just came and they got what they expected. And let me see. There's something. Just like what Dr. Wong said, it's very common to have some laser things like this one. And other than that, this is not the only things we have. I didn't turn on the light, so this is and we are still undergoing teacher training because for this part it's not as easy as laser cutter. We have to reform the G code by having different kind of bytes. For laser cutter, you could easily understand that with no different of bytes. So for CNC lathe, so you will see that is a lot of different size cutting tools. So we're still undergoing professional training with teacher, but I'm very happy this time because not only STEM teacher, we also got music teacher involved in, and that's why we have pace-based learning. And then the music teacher just tell me, Jerry, I would like to have a new project. I would like to making a guitar using CNC lathe with different material, and to see is there anything miracle happen. Now this is one of the things we did with the CNC lathe. And this is another example. Can you see? This is a CNC lathe crystal. We all did the homework for this part. For other than that, we're still under constructions. You could see this is a traditional cutting set. Yeah, because some students, as a maker, they may not be happy with working with computers. Of course, you know that in the 21st century, digital verbalization is no doubt a necessary thing in maker education, but we have to admit that some of the students, they are strong at traditional hand tools. So we still have the traditional cutting center, and even it is somewhat not only related curriculum, it's somewhat related to robot building. This is one of the students are still working in the robot lab. This is one example. We did not force the student to work. Actually, they just came. So this is one of the. Okay. It's very. Next time I have to prepare a better camera. So this is one of the robots in the robot. This is the overall picture of the robot. They will they go over. Oh, the student. Normally we will let the student to build the robot here. But actually, when they build a robot, the robot lab have to be close to the cutting center and also close to the STEM lab so that they can support by different tools. And one of the very important things in high-speed learning, like in STEM center, you have need a sufficient tools. You have this sufficient material. It's somewhat like this. In a robot lab, that is a lot of parts in the floor. And one of the things is the overall story of the robot lab. So if you want to start a robot lab, the student is not engineer. So you got to make sure two things is very important. Now, first of all, as mentioned, the place-based learning, that's very important for the place of the manager. You got to make sure that you can guide in the student for a kickstart. But of course, by the end of the year, or by the after a few years, maybe that student become a more genius. He can do things much quicker. However, at the very beginning, if you really want to start well, and you are not very familiar with that, you should employ a manager to kickstart it. That's very important. The second is that, as shown in the drawing, you got to have more than abundance of robot parts to let the student find error. From experience, if you want to train a robot genius, they are not learning from your talk. Actually, they learn by making mistakes. They are not professional engineers. They will not make the robot with the least material, but they will spend a lot of time and a lot of material for building up the robot. And some of the robot may not work. They'll put it on the side. If you do not have sufficient material, whereas the student have to recycle the parts to build the next robot, now that will be consume a lot of time and students are easily burned out. For the robot lab, last but not least, after that, other than the big, very big laser cutter, we will bring some small size digital visualization tools like this one. This is a small size laser cutter. So that this robot lab member, and this is less dangerous. So that sometimes we have to consider some small, more safe visualization tools for students and others. Okay, so that's very important. You got a lot part of it. So this is the general lab. So I'm done. Walk around to see. I may not be able to walk very far away from the Wi-Fi asset, but we just go out to have a quick look of the exhibition hall. So it's outside the room. This is the exhibition hall. This mentioned exhibition hall. So you can see the wall. This is a kind of based learning. We will last school to have. Normally, the school will have based learning, just like what I mentioned, the 2 rooms before. That will be Fab Lab, STEM Lab, Robot Lab. But some of the school may be listed that pace-based learning is not only technical, it's also have a very important way we have some thematic learning And the thematic learning leads a lot of parts, which they placed it in a eye-seeking area so that the student, they actually don't need to listen to you. They can learn by looking at them by themselves, and they raise questions, maybe like, Jerry, what is that? What is that you mentioned about? It's very important to rate the maker self-motivated learning. Now, I think that is somewhat why maker education is very variable. So after a walk, okay, I turn back the background. A moment. I go back to the background. No. Don't blur. Choice visual background. Okay, I get back the maker one. So we have a very brief our tour of our school special room. And next, let me go back to the PowerPoint. I will use around 2 to 3 more minutes, and then we'll go to the Q&A session. Okay, switch it on. Sorry. Hold on a moment. I go to turn back my PowerPoint. Okay, a moment. I will go back to the grand screen share. Oh, it's already there. Yeah, and we'll move on. Go away. Just focus on some picture because some of the part I haven't got enough time to translate them all. And that is how the room look like when you go inside there. And also that was some a big TV to showing the topic. Okay. And then for Form 1, just like was shown, that will learn 3D printing. And then later on, when the student are interested to make more things, they just come. Okay. And Form 2, mass strip design, sorry. Yes, design. So they were still using, they have accessibility. Yeah.
Are you sharing the PowerPoint?
Is that okay, or I'm not sharing?
Oh yeah, you're not sharing yet.
Oh, sorry, I will share now. Okay, it's okay now?
Yeah, it's fine.
That's right. Now for Form 2, we will have mass ear strip design related to academic. Students are still welcome to use 3D printing, but if no, they don't like it, okay, you can come to Mr. Jerry when you after lesson. Our lab is always open for you. Students will learn ergonomic design and also the user needs. And then Form 3, they will make hologram instead. Because we have more projects, but it's not mentioned here yet. We're changing our syllabus. I think it's quite the same. We are having professional development of doing MCU. Yeah, it's always that size of the virtual background. Yeah, when I try to show you something, that will be some choice.
Namaste. I think you can leave the virtual background off. And
choice virtual background. Yeah, I'm sorry. Our face is not very nice because it's a maker face. Now we are trying to our school using the qualitative 2F fund. We are not using the common box. We are designing MCU with specially for our students. So when you look at this MCU box, and the reason why we buy a CNC lathe, because later on we want maybe you still need 1 or 2 years for development. We will teach students how to make a PCB board with CNC lathe. Because using the acid to wash the PCB board is a very dangerous for students, but with the CNC lathe is possible. So this is one of the IoT projects we're undergoing teacher development. I think it's all the same. It's specially designed for our school. We find a company and design it. It's included a 8266 ESP chips there, and it can run with both Arduino C# and also mixedly. I don't know whether you know what is mixedly. That is a mixed mode MCU platform. Maybe I show a bit. 1 minute. So 1 more minute. Okay, am I sharing my screen now? Let me see. Not sharing. Let me click it again. Okay. Now, I just find some information picture because I don't want to turn on the software that would time consuming. Now, this can be in English or Chinese, and this is compatible for many Arduino-based MCU and also other MCU. The reason why we pick this platform because other than the student, it somewhat look like a microchip, but it's not the same. They can build by blocking, and then they can extract it by word. So this is very powerful for the teacher to teach the maker the language's logic. So this is a new trend, and also we have AI, but I think that will be a long story if I explain it. Okay, and next we'll get back to there. No, not this one. We make it quickly. Some whole school activities. This is some of the award that we got in the last few years. Okay, just like what I showed on the screen and in the room. Now, our school student also play in West Robotics, and this is the second year our school representing Hong Kong to go for the USA online competitions. And why we choose this platform? Because if you have a robot lab, I really agree with Dr. Wong said a robot is a kind of very good place for the maker learning. It can actually robot is not something special. If according to Lasser definition of robot, a robot is a series of system which can program by computer to perform certain mission. Now, this game is exactly what the Lasser told like. Every year, the student will be given a task. Now, for example, the task you show is stated in here. This year, the student have to think about how to build a robot to bring the base into balance board. And then they have to think about how to make the robot balance, just like what Dr. Wong said with sensor. Are you going with trial sensor? Are you going with optical sensor? How do you use the value returned from the motor to do so? But we get back to the topic. If you want to build a robot, you got to prepare those things. And it is good for you to tell your expectation to your senior before build up, because it won't be a very easy one. Okay. And other than we do it, we also share our facility to the community. We teach primary students how to build a smaller robot and giving them a chance to join some international level robot game. And last but not the least, we have a summary for that. Why we need place-based learning? Place-based education is stated as learning within a local community of students. Why we build a lot of communities? Because for place-based learning, one of the most important things is that you got a group of people to stick with that room. And they're not forced to stick with that room. They come laterally. But for me, I really don't want the room be shared by students only. There could be some teacher and student from other schools. I'm not trying to being big-handed, but we got a lot of benefits because somehow maybe our school teacher is a vocational school teacher. So they are strong as making things. But however, maybe that's my problem, not all teacher problem. Makers sometimes they are not romantic. What does it mean? They're very practical. Whenever they start a project, they have the idea how to end up a project. There will be some miracle when you include some people who are not makers in your project. For example, my principal assigned me to build up a new room. We're based on government funding for STEM education. I proposed. My principal asked me to propose for the member of the community, but at that moment, I directly tell my principal, I'm not going to take in charge of it. I would take up the making part, but I want some people from Chinese department, music department, or Chinese history. Why? Because they don't have the restriction. They will not care about whether the project is work or not. But that is romantic. And then later on, that's another story. We can find another chance to share it, or maybe next year when I build the room, we can have share. We want to build a metaverse experience room to tell Chinese story and history story, but that will be something later. So this is very important to decide to promote active citizenship and unite the handle real-world experience. You need some citizen to work in the room. That is some machine that I just showed you, okay, with some CNC lathe, robot lab. That's how it works. Storage, parts, number of tools, okay. And the last thing possible. Thank you. So that's the end for the brief sharing. So you may free to ask me some questions if any.
Thank you, sir. These are some questions from the YouTube live chat. First one is, what are the main skills a student needs to acquire for robotics building?
Robotic buildings, I will have a suggestion. It depends on what kind of robotic games you are joining. Now, that in the world, that is 3 to 4 very famous platforms. One of them is First Robotics, and other one of them is called Lego. Like Lego actually is part of First Robotics, but they have different streams. They have junior form and senior form. RoboMaster from Alibaba. So if you are going to talk about what skill your students will have to kickstart the robot game, I would like to answer in a fifth way. What skill your student got? You choose the right competition for the student who got most skill. For example, if I got a list of computer students, they do ICT, I don't have a fab lab or STEM lab, I cannot cut things, then go to MBOT, go to some robot who don't need mechanical change. For my case, my students, they are some practical students. They like cutting things, they like making gear. Now then I go West, because West have less programming elements, they have driver skill. Now when the students build a good robot, they play well. So don't think about how to force something into your student brain. Check what they have and start from what they're good at.
Thank you, sir. Now the next question, it's about Lego. Is robot built by Lego a good project for primary students to start with?
Well, I think just like was mentioned there, Lego could be one of the platforms for students who are not good at building, because Lego doesn't involve some crazy building. What means crazy building? Let me show you something. A moment, I come in 1 minute. Well, this is what we do. It's one of the parts. Actually, our students involve a lot of cutting, welding to build a robot. Now for Lego, it's some good points. They all plastic material. They don't need to screw it. I don't mean screw it up. I mean some screwing or interlock. So that is good. But other than Lego, I don't want to do promotion for. You still have a lot of choice for avoiding those mechanical building robot. For my suggestion is that primary student, you probably can stay with some robot which do not need a lot of mechanical change. And furthermore, one more hint, if you want to try competition, you want to build a robot lab for that competition, you better check how long does the robot game run. Is that stable? Is that happening every year? If no, your investment will become useless. If the competition is not stable, they are not going to go on there. So sustainability for choosing the game is very important.
Thank you, sir. Last question from YouTube. Where can we get more information about Dr. Yong's building card?
Sorry, excuse me. May I beg your pardon?
The participant asked, where can we get more information about Dr. Yong's building card?
Well, I'm okay. Please ask him to drop me a message. I will later on pass his content to you if he is willing to. I think the organization got my email, right? Yeah, maybe drop me an email.
Okay.
I'll contact later. Sure.
Okay. We will just pass the email in the YouTube live chat.
Yeah, other than Dr. Yuan example, actually paper prototype would be a very good kickstart of maker education. Yeah.
Okay. Thank you, Dr. Ng, for this a very meaningful session. We shall move on to the fourth speaker for today. Hold on, please. Okay, now I'm inviting the fourth speaker for today, Mr. Herman, which his topic will be about the M-square master. Mr. Herman, you can take over the floor, please.
Yeah, sure. Thank you. Good afternoon, everyone. So please let me share the screen now. Give me a moment. All right. So good afternoon, everyone again. Let me move the mic forward. All right. So if you cannot hear me clearly, please feel free to let me know in the chat box or the host may pass the message to me. Today, I'm going to introduce a topic about M-square master. And actually, it is a kind of it is one of the maker program or maker education activities that I want to share with you all. And the whole program name will be M-square master, designing, assembling, and playing the ukulele. Right. So let's start. Let me first introduce my name first. My name is Mr. Herman Yu Hinan. You can just call me Herman. And I'm the panel head of ICT and STEM education in Union Primary School in Hong Kong, which is DSS English primary school that I may introduce you more later. And I'm also the teacher professional development coordinator in the school as well. At the same time, I'm appointed in the Hong Kong Metropolitan University as a guest speaker and PGD instructor, and also a course developer of STEM education, CT, computational thinking education, and e-learning as well. And PGD in Hong Kong is certificate for teacher qualification for your reference. And I got some general article and conferences in the recent years as well, starting from 2021. If you're interested, you can go and have a look and contact me if you would like to work out together or try to discuss together about STEM education, computational thinking education, or maker educations as well. And the last one is the GCCCE 2022, which haven't started yet. I will be presenting implementing a school-based STEM education in a primary school later. So maybe I will see you guys there. So let me first quickly introduce my school to you all to give you a background information about what our school is doing. Our main vision and mission is to inspire students' potential. So we call ourselves, and also others call us, as a truly inviting school. So again, as said, we are an DSS school, direct substitute scheme school, and our MOI is English. So all of our courses are taught by English, and we got some highlights at school as well. First is ICT and STEM education, English education, music, and more actually. Yeah, so for our ICT and STEM education, actually, we have a long story that I may not have enough time to introduce you all today here. If you're interested, you can browse our school, ICT and STEM YYPS to know more. And in short, ICT, as everybody should know, information and communication technology, and everybody should know STEM, right? So our school have 2 lessons every week to run the systematic STEM education program. So it's like a core curriculum for all P1 to P6 students. It's similar to PE, music and visual arts lessons. They have about 2 lessons a week. So it's really similar. And again, similar to the 2 presenters just now, actually I learned quite a lot from Mr. Ng from Choi Secondary School, and also Astom from the Fung #1 Primary School. So our ICT and STEM education curriculum is similar to Astom's one, the Fung #1 Primary School. We both cover computational thinking education programs and also STEM education programs as well. And let me show you some makerspace we have that we just renovate our school to make a maker's room or makerspace to run the STEM or ICT curriculum. The first one is the STEM laboratory, and the second one is the computer room laboratory. We integrate IoT, Internet of Things, into the rooms, and also we have all the equipment like we have tons of 3D printers, laser cutters, and more to support students' learning. And those are some of the school awards that to recognize our school curriculum, our school-based ICT and STEM curriculum. And there are some students award. We got recently we got a champion in the world about coding for junior grade students. And to be honest, our school got a great connection with Mr. Ng's school, with Choi Secondary School. I want to take this chance to thanks to the Choi Secondary School principal and also the school, and especially Mr. Ng as well, to organize a lot of activities for secondary school and even more primary school to join as well. We got a lot of competitions joined with Choi Secondary School, and we got the Vest IQ robotic competition champion last year, and this year we joined that as well. There are some awards. And our school, we got a lot of maker projects that I may not have enough time to show all to you all. So today I'm going to take one example. Before I take that one as an example, I want to talk about the ICT and STEM education curriculum. We are counting it as kind of our subjects as well. So students' performance will be presented on a report card. So it's like we take it really serious. But unlike traditionally, we are not having the paper assessment traditionally. Instead, we will have a hands-on, ongoing, formative assessment to assess students' learning. And it's kind of just a relaxing maker project for them to learn by doing, learn by making. At the same time, then they can finish their projects. So we will take 70% percent of the total performance as the project, and other 30% as it's kind of a term and the summative assessment to be the practical test. All right, so today I'm going to take an example called the M2 Master Program to maybe demonstrate you all about how our school implement one of the Makers program. And to facilitate students' learning as well. So if you have any comments during the talk, or if you have any questions, feel free to leave your message in the YouTube or in the Zoom as well. So we can try to discuss and communicate, or we can learn from each other as well. So today's process it will be first, I will introduce what M2 Master is, and then I will introduce the project process that I will make good use of the engineering design process to talk about how we complete the maker program or maker activities with students. And then we will have a reflection part to talk about what is the importance of maker education and how we, primary school education, we see maker education. And then at last, we will talk about a quick conclusion to talk about what further steps that students or the primary school may take to continue with the maker education. All right, the first one, the M2 Master Program. Basically, Every single lecture is similar to STEM education. STEM stands for science, technology, engineering, and mathematics. So similarly, M Square Master, it takes different lecture head from different learning discipline. So M Square, because we have two M, one is music, another one is mathematics. And we believe that at this program we are talking about is mainly about ukulele. So I put M Square standing for music at the front. And then we have another learning discipline called mathematics, visual arts, science, technology, engineering, and also reading as well. So we have our M Square Master, and it's the concept that we have been talking about in the whole world, the integrated subject learning, or similar to STEM education concept. And our purpose is to use these activities with designing, assembling, and playing the ukulele for students to learn how to be a maker and how to learn the essential skills for the 21st century. And the program is, we have been running this program for 2 years already, and we got some awards for the curriculum designs as well. And this program is designed for grade 6 students. So in other words, this primary 6 students. So let's talk about the project process. So with the process, we take reference of the engineering design process to mention about how we run the whole program. But when we're talking about engineering design process, different author may have different ideas of the design. On the left-hand side, I have summarized different author or educationist idea of engineering design process into one. On the right-hand side, I found it online. It's my favorites. So I will take that one, engineering design process cycle on the right, to talk about the projects. So again, for the following part, we will separate into 3 parts. One is designing the ukulele. The second one, again, is assembling the ukulele. And the last one is playing the ukulele. So the first one, designing the ukulele, we have 3 different learning objectives. But more importantly, let's look at the engineering design process, or how we can train up the students as to be a maker in primary school. So first of all, for ukulele, actually, we will prepare a set of a new, not yet assembled ukulele for students to complete their task. But before that, they will need to first start to design their ukulele. So this part, visual arts, take place at most. And for maker, this word, for some of the educators, they will focus on making the products. But for our schools, we look at maker, this word, into different perspective. We don't just look at making the products, but instead we look at the soft skills that we have. We look at the hard skills, and we also design as well, arts as well. We count all as maker process. So first, define the problem. Students first need to design their ukulele. So that is the thing that they are going to do. And what we will ask them to do first is not asking them to, you may now start designing your ukulele. Instead, we really focus on the brainstorming process and researching process. That actually is more important than students can design the best work, to be honest. So we're in our program, a maker education program, we are not looking at the best design, like which one is looking the best. Instead, we look at the process, how they can complete the task. So first, we will ask them, hey, let's try to brainstorm some possible design that you have. And also you can try to do some research online to see what ukulele you have. And what our school will instruct them is not just simply to design a ukulele, but try to look at the ukulele to design the corresponding creative design. We look at the word creative. And then the next task is to establish the criteria and constraints. This is very important. Everybody, you may have a look on the picture on the right-hand side. You can have a look. There are 3 decided ukulele. And the middle one, there is some problem with that, to be honest. It's well designed, it's lovely. I can never do that, not made by me. I asked some art teachers to help to finish those as the sample, but I'm not good at arts, I couldn't do it. But for the middle one, there is some problem. Let's have a look. So if you have a look on the left and on the right, there will be a black part. We call it the fretboard, or we call it fingerboard of ukulele. Then later on, after we design the ukulele, we need to put we need to stick and assemble the fretboard to the body parts of the ukulele and the neck of the ukulele. And you can see that for the middle one, if you put the fingerboard or the fretboard on it, then the word STEAM, steam, some of the letters, at least I guess 4 of the letters starting from T to M will be blocked, and that would be so not perfect, right? After you put the fretboard, you may hardly see the letter S. Then there is some constraint that they need to think before they do. So thinking, preparing, before acting, before doing is very important. So our school emphasized this point to students when we want to train up them as a maker. Okay, then we will ask them to list out all the constraints and also list out all the corresponding or alternative solutions. And after that, we will ask them to select the best solution that they think that it fits best. And after that, we will ask them to plan, to write up a proposal or on a paper to plan how they design the ukulele, and maybe they need to draw it out on a paper first, and they are going to implement the plan after. Okay, so for test and evaluate this part, that is, we also emphasize this point in the maker activities. We don't want them to finish making or finish designing a product and that's it. That's the end. But actually, that's not quite enough, to be honest. Again, just now we focus on the thinking process. We emphasize of the critical thinking. We emphasize the creativity, and this part we emphasize the concept of doing the reflection. So they may need to reflect, and they need to know that for a maker, we need to know that clearly. For a product, there may not be perfect. You can never find a perfect product. That's what I will talk to them. You must find a room for improve, and there must be something that you can find, you can improve. So they may do the reflection, or they can evaluate the product that they made while testing. And if they find any problem, then they will refine the design again, and again continue with the cycle. So that's what they will do. It's a cycle that they will keep doing the same and create a problem, create a solution. And last, communicate results is not talking about communication skills like how well we present or how well we talk to others. But this one, communication results, is talking about how we present our works to others, how you're going to show your work to others. So there are some students' work for your reference. To be honest, I'm kind of surprised. They really can think about the design of the ukulele, especially the shape, right? The shape of the ukulele, and also the sound hole as well. It's kind of creative in the middle one. Of the sound hole, you can see that there is exactly the mouth of the characters. It's kind of interesting. And of the left as well. And actually those examples this year is our 3rd year to do this program, and students just make it last week. This one is last week. Actually, I got a lot of great pictures from the past, but maybe I can show you later if you're interested. Okay, so that part is for designing the ukulele, and for assembling the ukulele, that's what a maker need more for assembling. So for the ukulele, you can see on the right, for primary school, I will provide the body of the ukulele to them, as you can see on the right bottom corner. But to be honest, if let's say after 2 years, if I think that students are capable to do it, I will not provide them with the neck of the ukulele. I will not provide them with the body of the ukulele. Instead, they may need to find environmental friendly materials to make the ukulele instead. So that will be more maker as well. But now in this stage, first, because it's new curriculum, it's newly developed. So we will first provide them the basic materials for them to learn. So first, define the problem. To define what they are going to do, they are going to assemble the ukulele accordingly. And now let's say for the problem, they are going to stick some of the part, for example, the neck of the ukulele and the body of the ukulele. They need to stick them together. Another part is the fretboard. And we have some part that they need to use the screwdriver, the tools to assemble it as well. But then first, let's brainstorm the possible solution. If we are talking about sticking the body, the neck together, and the fretboard together. For most of the adults, we think that it's easy. We just put the glue in, right? We just put the glue, apply the glue on the interface, and then we can just stick it. But to be honest, I tried it several times. That is not as easy as what we think, and especially if we are talking about primary school. In primary school, they may not have such an experience in doing some hands-on tasks. Then there are lots of mistakes, lots of difficulties that they may face later. I will talk about this more. But first, what we will do is, now we will take this chance to let them discover more. Actually, we provide a chance for them to choose which one they want to use. Which of the sticky stuff, the glue they want to apply to the ukulele. So I will ask them to do research online again, like the previous one. And then they will see, now we are talking about ukulele, and we will see what is the materials of the ukulele. Actually, we're using a wood one. It's not a plastic. Then they will see, they will search what is the best glue for wood. Then they will search it online to have a look, and then they will establish the constraint, the criteria, and so on. And last year, students chose to use the hot glue gun, and it's fine. It's totally fine. I let them to choose it. Then I will prepare it accordingly. That's what I will do. I don't want to have a maker education program that I ask students to do. I prepare all the things for them to do. I give them a guideline for them to do. You just need to follow my task to do. That is not great for maker education. And unfortunately, to be very honest, in, let's say, some countries, some primary school, you must see in some school that they do because they want to do, they do because they need to do. Then they will do something like the maker education programs, but actually you cannot facilitate students generic skills like creativity, problem solving skills. You just ask them to create a product, that's it. So in this step, yeah, we let students to choose it. And this year we're going to use the now-free glue. Then they're going to further study about the constraint of using it. And basically, if you used it before, you may notice that it actually takes up to 24 hours for the glue to dry. That is the most important thing. Why? Because let me show you the pictures. Okay, because when we apply the glue to the body and the neck, and also we stick the fretboard as well. Actually, when the glue, when you just put the glue for like a few minutes, actually it's not kind of very sticky, and it will probably move. And the worst I find that is last year, the students try to apply the glue on it and then put the whole ukulele into a bag. And after he or she get home, and he just put the ukulele somewhere for a week. And after he or she take it back to school, the whole ukulele becomes terrible because like the neck and the body part is twisted. And also the fretboard is something like going to other places that are not in the correct position. But the glue dry and then it comes problematic, right? So there's a problem. We need to wait the glue to dry before we continue with the next task, right? So they will consider alternative solutions, or they will find a solution, the best solution. Do we choose another glue to use if now it takes 24 hours too long? Do we find another glue? But they find another way. All right, then they find an approach. They think that this is the best. After we apply the now free glue, then actually they can use a tape. They can use the tape to fasten it, to tighten it, to hold it, to make sure that the fretboard, the body part and neck, they are in the correct position. And after 24 hours, they'll just take it away. I think that you solve a problem. That's really good. This problem is not solved by me. I'm not the one who tell you to do then. You are the problem solver. That's what I want to see what our students achieve in terms of maker education. So design, they will start to, they will plan how to do it, and they will implement it using the now free glue. And again, they will do reflection. Even though they don't need to stick it together, they don't need to like break it up and try to fix it again, but they still can do a reflection to see that next time, all right, maybe now free glue is not best. Maybe we can choose another one. That's what we emphasize as well. All right, so here are some pictures for your reference to see. And I want to discuss with some something that is really important, especially in primary school. Actually, you may not see those problems if you're working in secondary school, or if you're your students and secondary school student. So for screwdriver, primary school student, they do not have any experience. Some of the students, they do not have any experience in using the screwdriver. And the funniest one is, the most funny one is, I find that there is a student, he is holding a screwdriver and keep twisting it. I like using two hands to twist it. And yes, I did not stop him, to be honest. I'm such a bad teacher. I did not stop. I just left him to discover. That is one of the approach of teaching, right? Discovery learning. Let him to try. And after 2 minutes, finally there is a student go to him and say that that's not how you use a screwdriver. You need to twist it clockwise. But I think that's really good experience. Then actually at that time I stopped the whole class. And I just discussed with all the students after most of them finished or started using the screwdriver. And we discovered together how we use the screwdriver, why it doesn't work. Oh, because we look at the screw, everybody, then we will take up the screw and to have a look, and we take a screwdriver as well. We will think about the concept behind. So I'm not telling him, you have to turn the screwdriver clockwise to complete the task. If I tell them, then I will be just delivering the message to him. The thinking process did not appear. So I'm emphasizing the thinking process. And next time they may need to, he or she can think by himself, be a self-independent problem solver. So I talked to the whole class, and then we can try to think together why it doesn't work. Oh, then actually when you trace clockwise and anti-clockwise means that +1 and -1, the concept is something like that. So you did nothing. Very good. But I really appreciate his hard work. I keep doing it for like 2 minutes. And I got another problem for using the screwdriver. For the ukulele, when I ordered the ukulele, I asked the provider not to make the small hole for students to fasten, to tighten the screw. Because I want them to use to think about how they can do. Because again, there's many students in this case, about 1/3 of the class. If they do not know how to use a screwdriver, they will be something like using 2-3 fingers, doing something like slowly keep twisting the screwdriver, and then you will know that yes, actually it works. It keeps twisting, turning clockwise. It's correct, but and then some of them, they really wondering why. Hey, Mr. Learn, just now you say we should not turn it clockwise and anti-clockwise over and over again. Then now I turn it clockwise, why it doesn't work? And then we study, actually there is a proper way to use the screwdriver. The picture I saw on the right actually is not very proper. I just want to show you how they will use. That's how they hold a screwdriver. But actually we should use our palm to hold a screwdriver. And actually when we need to use the screwdriver, the screw, some type of screw, they can apply the pressure and make the hole, right, for the wood. So I simply ask them, okay, then you need to think about that. I'm not the one who tell them how to do it. Instead, I ask those who fail to do it to observe the one who made it. So in this one, actually, it's kind of a skill that, oh, well, we do some kind of a remixing, but not remixing a product, but we look at others, we mix how others do, we observe, we copy, we learn. Actually, we use the word learn from others. Oh, well, they use a palm, they apply pressure, they use some pressure to do it when they twist the screwdriver. And then when we study together, that's how they can learn. And next time, when another problem comes, then actually the first thing they will do is they will not raise up their hand and ask the teacher. My class is well trained now. They don't really ask me questions. They ask others questions, and they got a really good observation skills. When they don't know how to do it, they will see how others do. And also when I have some kind of this kind of a maker education program with them, I will provide them with an iPad. If they are not the BYOD bring your own device class, I will reserve iPad, let them to have one each. And then they can have the skill of doing research online when they see a problem. So that's what I want to emphasize as well in our curriculum, a maker education. We want them to be an independent learner, independent problem solver. Another one I like the most, this one is also one of the key important learning objectives of STEM education, of implementing STEM education, that is the collaboration skills. Sometimes we need to understand that we need to know that some tasks we cannot finish it by ourselves. Actually, most of the tasks, if you have the good collaboration skills, that may help you to enhance the productivity that students need to learn as well. So I did not ask them to work in group, but I can see that in the class every single time. They will work together. For example, this program, every single student, they need to work on their own ukulele. They need to make one each. But I can see that some smart students, they will ask others, hey, let's team up. Okay, you and I be a team and let's finish one first. You finish my one and then I can help you to finish yours. And of course, in primary school, we will see some situation like, why don't you finish my one first? Of course, but it's totally fine. So we emphasize of the collaboration skills, let students to know that the collaboration helps a lot in problem solving. Another one is, again, I do not provide guidance quite a lot. If we're talking about some theories, and then we can talk about a scaffolding, right? We can talk about a constructivism theory, the social constructivism theory. We can talk about Piaget and so on. Those are talking about, you can see that I really let him discover, but our role, the teacher's role, is like a facilitator. And what I always tell my students is, I really like seeing you guys to make mistakes. That is I'm more than happy to see you made a mistake than you easily finish the task. Because if you can finish the ukulele in just 5 minutes, let's say, okay, 5 minutes, means that, oh, you know how to do it, right? You are just consolidating how your skills. It's like a consolidation. But if you made a mistake, if you fail to do it, it means that you have a room to improve. It means that you will have a chance to learn the new skills. That's really good. So they are really kind of a new maker. I want them to have like an independent maker again. But some mistake that I take some pictures on the left, the tuning pad. Okay, this is the tuning pad. Originally, we give them the whole tuning pad. is on the left photo on the right bottom corner. Oh, sorry, right top corner. We give them the whole tuning pad, but there is a one student, two students. One of the students, he saw that there is a gear on the tuning pad, and then what she did is use the screwdriver to twist it anti-clockwise, and then she broke the not broke actually she separated finished the tuning pad into 1, 2, 3, 4, 5 parts. That's I think it's good, but yeah. So in this case, I talked to the students that, oh, we should think about the reason behind why we do that before we do it. So preparation or preparating or thinking is more important than doing. And I asked her, why you need to separate those parts? What is your next step? And then she realized that, oh yes, why I need to do that? Oh, because I did not tell them to do it. I did not tell them not to do it as well. But this one helps them to think, oh yes, what is my next step? And then she just sincerely tell me, oh, I don't know, I see there is a gear, I see there is a screw, so I just want to do that, and that's it. So again, we are a facilitator, we help them to learn. Yeah, so next time think about your next step first and think about what is the purpose of doing that. Another one on the right bottom corner, similarly, she assemble the tuning pad before thinking, make it upside down. So, but she fixed it, no problem. But you will see that there will be 1, 2, 3, 4, 8 small holes on the front of the neck of the ukulele. Another mistake, but it's totally fine. We want to see mistake as well. Another part is about the strings. This one, to be honest, they need to tune the ukulele. And if you have some music background, then you should know that when you tune it, you are going to fasten to the ukulele, the tuning pad, and then the string will become tightened. And in that case, the ukulele will easily break if you did not wait until the glue to dry. This is another very common mistake. Then I would just let students to do it, let them to fail. I enjoy students failing. So let them to fail, and then they find out, oh, Mr. Leung, why my ukulele broke? The neck and the body bar separate again. Isn't that, you say, how we discussed about that narrow frequency is really strong? And yes, and then we can find that, you did not wait for 24 hours, right? You did not wait until the glue to dry, right? Yeah. So the last part, playing the ukulele. I think that I will not have enough time to cover all the parts. So playing the ukulele, if you're interested, we can talk about that later. But now I want to skip to the reflection parts. The importance of maker education. During the example just now, I believe that you should see that what me or our school look or see maker education is. And you should see how important maker education is as well. And for myself personally, I think it as the problem solving. The most important part is problem solving. And then we look at 4 different components. One is they need to be creative. So creativity is kind of a generic skills. Critical thinking skills. It's also important as well. We want to train it up, and through the maker education, we can help them to equip those. Another one is we discussed about that just now, collaboration and communication skills as well. So those are really important, and that's why recently we have those STEM education, computational thinking education, maker education. Those are not new, but now it's being emphasized again recently in the whole. In the 21st century, that's what all students like. And we in primary school, I think that yes, as soon as students got the experience or have those STEM education or maker education activities, which may help them to equip those skills faster and easier in secondary schools as well. So this one, I think that some of you may have heard about this, right? Eston mentioned that if I had an hour to solve a problem, I would spend 55 minutes thinking about the problem. 1 hour, we got 60 minutes. Oh, yes, we know. So 55 minutes of thinking, but we would just spend 5 minutes thinking about the solutions. So I always emphasize to students that, especially in the make progress process, we should emphasize the importance of preparing, importance of thinking. So thinking skills is really important, and reflecting skills as well. And at the end of the maker education, we really want to see, of course, some innovative products. In this example, the creativity part goes to the design part, but not the assembling. But assembling part will be just like a part that everybody will do, is a making process. And for the next step, for the further step that we may do is, actually, I really want them to observe what the ukulele that they have on hand, and then they can try to use environmental friendly materials to make something like that. And before that, we will ask students to complete a learning report. It can be presented by using photo. It can be presented by using words. Because some students, they are not good at written, but we cannot not providing another alternative way for those who are not good at written tasks. So I let them, you can present it by using video recording and any alternative way. And those what they will be doing. Okay, so we have done design, assemble, and play the ukulele. And the rest, we will have some lesson time to cover with them, like some foundation of the DIY ukulele, for example. The relationship between the string, the length of the string and the sound, the pitch, right? And also we can discover about the thickness of the string and also the pitch as well. Those are some actually science related concept that they may know more, which may help them to be a maker, to further evaluate their work, and also to be creative, to create new products as well. And other things is similar. We will ask them to, this one I want to mention, microbeat tuner. We will do some coding part with the ukulele as well. We will ask them to use the microbeats with the micro platform to do the tuner, to tune the ukulele, help them to tune the ukulele. This is a very fun add-on project that students love the most as well. And I think that's all for my part, to demonstrate you all about how we see maker education, and one of the example that we have done that we want to facilitate students learning in making products as well. So thank you, everybody. So if you have any questions, feel free to let me know. Thank you.
Thank you, Mr. Herman. A very detailed explanation. Just one question from the participants. A participant asked, was there any particular motivation why your school chose to make a ukulele?
Yes, let me repeat your questions. Why our school, what is the reason why we chose making ukulele, right?
Yes.
Yes, that is a really good question. To be honest, why I always emphasize the word school-based, because we should not have a center curriculum for every single school, because every single school, you have a different practice, you have different mission and different aims. And for my school, I can tell that, let me be humble to tell that our school music curriculum is really, really good. I think okay, it is the best in the Hong Kong as well. I said it. So with this point, I want to integrate the environment that all students, they like music very much. Our music panel has developed a really, really strong and good and positive culture in music. Everybody, they like it. And they love to use recorder before every single day. And that is, to be honest, kind of annoying. And in school time, I can hear the sound of recorder during recess, after school, morning, every single time. But that is one of the points, that because of the music culture. And the second point is because of the COVID-19, like the Fung #1 primary school, as Tim mentioned that, they mentioned about the situation of the pandemic, COVID-19. And I also think about that as well. Everybody need to wear a mask. How can they continue with the recorder? Are they going to make a hole in the mask? Of course not, right? So ukulele is really cool. So I'm the panel head of ICT and STEM, and I have my own subject to implement this program, but I am still working with all those departments to make this ukulele program happen, like the Chinese, English, and mathematics, and especially music as well. So the music panel has arranged and developed a new school-based curriculum for P6 students to learn ukulele. And now actually they all know how to play the ukulele, but I don't. so that's the reason why our school chose to use the ukulele. So this one just an example for everybody, but not copying from mine. But you may need to think about what kind of program, maker program fits best for your school. Yeah, thank you.
Okay, thank you, Mr. Herman. Thank you for the meaningful session. So everyone, that wraps up our third Makers Talk. A very gracious thank you to Mr. Wong for taking over Mr. Eric Yeo on this topic about innovation of tomorrow and how we develop from the different industrial eras to Industrial 5.0. Also, a special thanks to Mr. Aston on his talk about the challenges and opportunities of school-based and computational thinking in STEM. He explained on his detailed explanation about the methods developed by the school in order to bring forth this goal. And also a special thanks to Mr. Ng on explaining the whole maker's mindset on how to prepare for a project and how to set students and motivate them to not get too overwhelmed with robotics per se. And finally, Mr. Herman, a recent speaker who gave a very detailed talk on the M square master. I'm sure it was a very good explanation on how everyone can take notes, even though it was a primary school example, but that step-by-step basis, especially the engineering workflow on how to start the project until the very end of communication was a very beautiful thing on how everyone can use when developing their own project. Now, before we end our session today, let me just remind everyone that this is our website for our event with Makers at USM, which will be at International Virtual Fair, which will be in August. We will send this link again to the YouTube live chat. So everyone can have a look here on all the important details in introduction. You can look at the videos that we have presented to you. Now, just reminding again, today is the 30th of April, which is the last day for registration. So if you have not registered, you can get the registration form from over here and do so with the registration. These are all the details that you should know about. And for those who have registered, you can go on with your submission process. The submission must be in English. Three very important things which are required for your submission for those who have registered. Firstly, is an abstract, which is not exceeding 250 words. Second is a one-page quad chart. Now, for those who are not familiar with a quad chart, what is a quad chart, how does it look like, and how to do a quad chart, we have given an example of a quad chart right here. You can check it out on our website. It gives you the design template of how a quad chart should look like. Basically, as the word goes by, quadra means four. So 4 quadrants here. So there are different project description, creativity project, prototype, effectiveness. Everyone can go through it and get to know how to do a quad chart. And the third criteria for submission is going to be a 5-minute video project of a video of your project, whatever project that everyone's doing. So everyone can have a look at the details here. And yeah, so that will be all for our Makers Talk. We have successfully gone through all 3 Makers Talk. And for those who weren't able to attend any one of those 3 talks, we will be posting a recording of all the 3 talks in our website. So stay tuned for that if you're interested. And yeah, do remember to register. This is the last day, not the last week. This is the last day for registration. After today, you will not be able to register. And thank you everyone for attending. Happy holidays. Travel safe and stay safe while driving back home for anyone who is going back home for the long break. With that, we will end our session in a few minutes. Thank you everyone, and thank you again to all the speakers.